Hello, everyone. Thank you so much for joining us today for this really exciting webinar on embodied carbon in the built environment. My name is Julianne Tice. I'm a buildings policy advisor at the Energy Efficiency Council, and I'll be your host for the next 90 minutes. For anyone who's not familiar with the Energy Efficiency Council, we are Australia's peak body for smart energy management and demand response. Before we get started, I would like to acknowledge the traditional owners of the lands on which I am coming to you from today, and that is the land of the Wurundjeri Woiwurrung peoples of the Kulin Nation. I'd like to pay my respects to their elders past, present, and emerging. Today's webinar covers a topic that is increasingly emerging in conversations around sustainability in the built environment. And just judging by the number of registrations on this webinar, it's clearly becoming a topic of interest, which is really excellent. So just to give a bit of flavor of what we're going to talk about today and a bit of background, which our speakers will elaborate on in just a little bit. Operational carbon, that's the emissions associated with the day-to-day operation of a building, has really been the main focus of building life cycles for quite a while because that's something we can measure consistently and in real time. And it's something we largely know how to work on reducing, although of course, actually taking strong action on that is another matter. Embodied carbon, however, has been more of a sideline issue up until it's begun getting more recognition in recent years. And that's through a few different things that are happening. We've had the creation of the Materials and Embodied Carbon Leaders Alliance, and we've had a number of reports in recent years from the Green Building Council of Australia, the Grattan Institute, and others. And we'll share some of those through the chat if you'd like to have a look in the coming days or weeks. So just for some definitions on embodied carbon, which again, the speakers will expand upon. Embodied carbon refers to the emissions associated with the manufacture of building materials, construction of buildings, maintenance and repair of buildings, and the end of life of those materials. Measuring embodied emissions is quite complicated, so defining the scope and measuring in a standardized way is quite a challenge, and that's something we'll talk about today. Embodied carbon refers in part to the precursor to construction. So while we are talking about the built environment, really we're talking about the manufacture of building products and the emissions related to the manufacturing industry. The creation of building products has historically been quite energy intensive, especially for building products such as steel and cement. And that's due in part to the requirement for high temperature process heat to be involved in that manufacturing, and also the use of chemical reactions. And those things are quite difficult to decarbonize. And once a building is built, those emissions are locked in. So it's really important that we start looking at the emissions of those building materials soon, much before 2050, and we need to reach net zero, and much before even the design phase of a building and before construction begins. It's also quite important to look at the embodied carbon of buildings to ensure that Australian industry remains competitive as the demand for low carbon building products increases both domestically and internationally. And to give a bit of a statistic on embodied carbon in Australia's built environment, embodied carbon currently accounts for 16% of the emissions associated with Australia's building stock in 2019, that is, and that's projected to increase to 85% in 2050 as we begin decarbonizing the operational emissions associated with buildings. Means of measuring and disclosing embodied carbon are needed, and it's really important that we harmonize these efforts so that we're all speaking the same language and able to effectively take action on this issue. And I'm very excited to say that we have some great experts from academia, government, and industry with us today. So it really highlights the fact that we have a few different sectors or people from a range of sectors working on this issue already. And now we need to bring all of these people together so that we can talk to each other and come up with solutions in collaboration. So that is what we're here to do today. And I would like to thank the Department of Climate Change, Energy, the Environment, and Water for their support on this webinar. The department supports the Energy Efficiency Council on supporting Australia's engagement with the International Energy Agency's Energy in Buildings and Communities program. That's a global collaboration, research collaboration on various topics within energy and buildings. And I'll elaborate on that slightly when I introduce our speakers. And we'll hear from them shortly, but first I'd like to pass over to Monica Richter. Monica currently represents the Worldwide Fund for Nature as the Program Director of the Materials and Embodied Carbon Leaders Alliance, or MECLA. Monica will give a few words on MECLA, and then I will come back and run through the agenda for the afternoon or morning, depending on where you're located. And I'll pass it over to you, Monica.
Thank you, Julianne. Lovely to be sharing the podium with you and all of you today, and to be co-hosting this exciting event. So MECLA is all about collaboration, about how do we work together in industry to create everlasting change in that upfront and embodied carbon that you explained so well. So just a little bit of background. MECLA, some of you will be familiar with it, some of you won't be. In 2018, 2019, sort of companies, a lot of the developers and head contractors were setting science-based targets, and they were starting to talk to their supply chain, and they were having a real struggle sourcing low carbon materials. And so it was the conversations with them, many companies, the likes of Lend-Lease, Investor, Dexus, and Stockland and Mervac and many others, that we discovered that there was really value in coming together and thinking about what those interventions would be. So we did a piece of initial research with Precinct, a small consultancy firm who has an office here in the WWF office, and sort of sitting around the water cooler, we were brainstorming how we would go about this work, and we put together this systems diagram, which you can see here, which was our foundation research to really identify what those, there's no one solution to how you actually accelerate the uptake of and address embodied carbon barriers, but collectively we were able to do that. And thankfully at the same time, Lend-Lease were undertaking a similar research piece, and we launched in 2020, and then we officially launched MECLA in April 2021. So we focus very much about helping companies to achieve their Paris Agreement targets, circular economy principles, and taking that systems approach, we do it through that, but demonstrating that demand piece is really, really important. That carbon evaluation framework, which some of you work in that area know that it's a very, very complex and difficult. Knowledge sharing. And this webinar is one of those elements about best practice case studies and that knowledge sharing, developing common language. How do we get procurement agencies specifying it in a way that doesn't have unintended consequences? What are the risks for engineers associated with adopting innovative materials, use of EPDs or not? And then the steel, concrete, aluminium, which are the three big areas of embodied carbon materials, and also engineered timber and many of the other materials that are in there. So that's our purpose. We have government hand in hand with industry through a government navigator, and that's been really, really valuable to have a New South Wales government navigator who can bring the different parts of government to the table to have those conversations and test their policy, draft policies with MECLA members to just road test and ground truth whether that works or not. So both for their purchasing power as well as industry policy enabling that to happen. As you can see, we have many organisations right across industry supply chains who are supporting this, including the finance industry and local council. And we are a do tank, so it's very much about rolling up sleeves, contributing to the work of the working groups, and contributing to this. We're not an industry association, we're an alliance of organisations. We're going to be around for a short period of time to intervene and help to accelerate and address these issues, and then we'll move on. So our working groups, you can see those working groups, they're very much based on the purpose and the principles that we've established right at the very beginning. And just as an example, one of those working groups, working group one on the demand side, have been working on a pledge prerequisite. So for head contractors to pledge that they have an embodied carbon target as a prerequisite for tendering for government work. Now, we've been socialising this across a range of different agencies. Government agencies are quite interested to explore this in more detail. We've tested it with head contractors as well. So that's just one of the examples of that kind of intervention that we think is really clever. got a range of priorities, including the policies, procurement levers, how we support manufacturers to be investing in lower carbon materials. That skills knowledge is really important, and improving the data. Data we know is fundamental to this as well. And just to give you some idea, for the demand side to be hearing the challenges of the supply side, and for the supply side to be hearing how ambitious the demand side is around the commitments that they've made. And we held an event in May where you could really see both sides and hear from both sides at CEO level representation what those critical messages are, and and government as well. And I think one of the key elements to MECLA's success is people are really generous with their knowledge. It is a pre-competitive model, and therefore people have been really, really generous with their knowledge and contribution, and a huge number of hours of in-kind contribution. So I wanted to leave you with some thoughts around what those policy levers are. We've done a little bit of work for the federal government MPIT on best practice policy development. We've scoured what we think is best practice across different parts of the world. And there are many levers to achieving change. Some of the policy levers you can see there that are more than just about embodied carbon and energy efficiency. They need to be whole of systems approach to be able to drive that level of change. We'll come back to those in the policy discussion later. And my penultimate slide, the scale of the transformation required. We are in a climate emergency. We need to be thinking transformationally around scale and impact. And see here two slides. The first slide, in 1900, Fifth Avenue, New York, you've got one Ford motor vehicle and the rest a horse and cart. And you've got the other slide there, only 13 years later, and there are no horse and carts there, just the Ford motor vehicle. So we've done it before. We've made those transformational changes before, and I think we can have a level of ambition there as well. So those are my contact details. I'll put some links into the chat. Really look forward to the conversation as we go through and hearing from the speakers as well, but delighted to be here today. Thank you.
Thanks, Monica. It's really great to hear from MECLA, and that's a really interesting picture you showed there at the end. Really shows that things can be done. It's been done in the past. And if you hadn't said when MECLA was founded, I really would have thought that it was a much more mature organization. So really a lot of work to bring people together in just a short amount of time. So congratulations on that. Now I'll quickly run everyone through the order of proceedings for the next 90 minutes or so. So first we'll hear from Greg Foliente and Thomas Luskendorf, two representatives from the IEA EBC program that I mentioned earlier, who have been completing research on the life cycle impacts of buildings. Their presentations will give us a view of the entire life cycle of buildings and related emissions. Second, we'll hear from Ivana Brown from the National Australian Built Environment Rating System, or NABERS, on their work around developing a framework for measuring and reporting embodied carbon in the built environment. Ivana will focus on more of the building side of embodied carbon rather than the product side. And finally, we'll hear from Cyril Giraud, an expert working in the product manufacturing space, about how manufacturers are beginning to deal with the emissions associated with their products. Cyril will talk about cement, and that's really just one example of many different types of products that are used in the building supply chain. Following presentations from each of these fantastic speakers, we'll hold a panel discussion during which we encourage you to submit questions via the Q&A function. And if you have questions, if you think of questions as the speakers are going along, feel free to throw them in the Q&A and we'll get to them during the panel discussion. So our first speakers for today are Greg Foliente and Thomas Luskendorf, as I mentioned. Greg has many roles, including as enterprise professor at the University of Melbourne and he is the president and chair of the board of directors for the nonprofit International Initiative for a Sustainable Built Environment, or IISBE. He has worked with industry, government, and international bodies such as the UN Environment Programme and the UNFCCC, and is the Australian representative to the IEA EBC, Annex 72, or research stream, assessing life cycle related environmental impacts caused by buildings, and also Annex 73 towards net zero energy public communities. Thomas is director of the Center for Real Estate at Karlsruhe Institute of Technology KIT in Germany. For more than 20 years, he has focused his teaching, research, and consulting on the integration of sustainability issues into decision-making processes along the life cycle of buildings. Thomas is a founding member of IISBE, involved in standardization activities at the European and international levels. He's one of the key architects of the German Sustainable Building Rating and Certification Schemes, and he is the German representative to IEA EBC Annex 72 and leader of one of the subtask 1 on harmonized methodology guidelines. So I will hand it over to you, Greg and Thomas.
Hello, good afternoon or good morning to Thomas. So my presentation today is about the life cycle greenhouse gas emissions in building construction. As a bit of brief overview, past, present, and future. So I thought it's better to say back to the future. Now, Thomas and I have worked a fair bit over a period of time and across sustainable built environment, but in the last 12 years, especially focused around the IEA on embodied impacts. So we've made presentations and various papers together on various aspects of this, including biogenic carbon and benchmarking and stakeholder views and perspectives. The whole life carbon topic has exploded in the last 5 years or so, and we can see that in many of the reports that we have and continue to be released across the world. And I say catch up because eventually, finally, the whole of the sector in different parts of the world are into whole life carbon. But we can look back 100 years ago in Germany, in the local building requirement, for example, in Weimar, where when they were planning the first Bauhaus model house, there was a requirement for building materials that have the least amount of coal. So in other words, embodied coal. And so the design procedure, apart from the requirement, required not only that there's a improvement of thermal insulation and reduction of energy consumption and heating costs and construction costs, but the least amount of coal in the materials and the processes. So in a way, it's a life cycle building energy approach, which we have not now caught up with after 100 years. There are many other countries that obviously have done many aspects of this over the years, including in not only Germany, but also in Switzerland and other places. Around mid-2000, 2005, 2009, I was a consultant with the UNEP Sustainable Buildings and Climate Initiative, where there was a big consensus across industries around the world to do a common carbon metric, which we developed for COP19 in Copenhagen, laying out the whole life cycle. But this particularly focused because of the difficulties and many issues around embodied carbon to exclude it. So this was purely on operating carbon. And before that, because even though there are a lot of developments in the environmental assessment through the ISO 14000 family of standards starting from the mid-1990s, coming out of the recommendation of the UNEP CITAC Life Cycle Thinking Initiative, the development of, for example, standards for life cycle assessment, which ISO developed and expanded over the years across areas of environmental management and now also broader sustainability assessment, including social LCA, for example. And there are more that got included in this ISO 14000 family around, of course, carbon footprinting and greenhouse gas emissions. Fast forward maybe 10, 12 years after that first set of standards of the methodology of life cycle assessment, the problems and challenges were on databases. And so UNEP-SITAC put together a little book on the guidance on 2011, which I participated in Japan in 2011. And then, of course, during that period, we had to focus on the building construction because the work of the UNEP-SITAC and the ISO were general across industries and across all manufactured products, where there are a lot of unique kind of issues to address and details to deal with in the building construction industry. And the reason, in fact, that's why we excluded them in the original common carbon metric of UNEP was because of all these unresolved issues of harmonization and definitions and details and understanding of some of the issues. So Annex 57 in that period looked at many, many issues and in detail. And one of the things that's important is the recognition of the country variations of energy mix and greenhouse gas emissions, because many places were using life cycle assessment data from different countries. And when you compare the intensity and the energy mix, they're very different. In Australia, a lot of consultants were using ICE, a database, for example, from the UK, which is clearly have a different profile. So unless we do these adjustments, we cannot really use another country's data. And we also developed or written many reports and papers about some of the important factors. And one of them is the transparency in embodied carbon data in construction, for example, that if you're reporting the numbers, that you also need to identify the methodology of developing or establishing that number and the system boundary within construction outside of the product life cycle, but also what are included or excluded in the emissions. And later on in Annex 72, Thomas and many others in the group also clarified many of the details that are just a mismatch and that are necessary in terms of understanding, that are necessary for harmonization. So, for example, there are a lot of focus on the basis of LCA data, whether it's from input-output table or a hybrid approach or process-based approach. We compared them in Australia in the product stage, for example, from cradle to gate to the product level, and you can see that there are differences. This is for housing. Two types of houses of the different things that you would get. If you look at the different types of buildings, you also get different results. And this is for this reason that many people do a lot of discussions around this topic. And then, of course, we focus, because most of the focus were on new buildings, we have to focus on the building stock and the existing buildings. As discussed, this is very important, but the level of granularity is also important to determine what actions would be helpful. So when we look at, for example, all the databases in Australia that's been used in industry, in consulting, but also in research, you can see the list over here. And obviously, we'd like to use the Australian data, but many consultants and other research also use the non-Australian data. But the focus has always been on the methodology process. And there's a lot of discussion around this. So what we developed in Annex 57 and later on Annex 72 is to look at the fact that there are many stakeholder groups that we've already seen in the MECLA diagram in the ecosystem of building and construction sector, and that these different stakeholder groups have different roles. Even if you're one type of stakeholder, you have different types of decision-making contexts. And so if we only focus, for example, on the three types of stakeholders, the product manufacturer, the design professionals, and government, they have different primary roles, and they have many decision-making contexts or questions to ask. And the idea really is that the LCA data sets will have different relevance to these different questions. So it's not a matter of which one is the best. It's a question of what's the most appropriate to address specific types of questions, and not to be consistent in comparison. And so Annex 72 then look at and focus more on the integration of embedded and operational impacts. Some of the highlights are in bold in this overview slide about Annex 72. And this was our first meeting in Copenhagen, and it's finished now and in the process of of this dissemination and finalizing the reports. One in the last meeting was in Switzerland, which led to the Monte Verita Declaration on Built Environment with Planetary Boundaries. And you can see again that the actions recommended by Annex 72 are across these different actors. It's quite important that we focus on what everyone can do, because not one sector can do everything that needs to be done. Point in closing 2023 onwards, even if we decarbonize the whole energy sector, for example, you can see that the 27% is still need to be addressed from other sources. And in Europe, they're looking at not just the new buildings, of course, but the existing buildings by 2030 to have targets and disclosure of global warming potential. And so we need to scale up from individual buildings to buildings in cities and regions, and from existing buildings to new buildings. But the key is the whole society actor-enabled approach. That's why we focus on the roles of different players and actors in the ecosystem. Thank you. Thomas.
Yes, thank you. So here I like to jump in. My name is Thomas, dear colleagues, dear ladies and gentlemen. So I have to start my presentation and I start my video, and here we are. So yes, let's talk about embodied carbon. We will do this in the spirit of Sustainable Development Goals. This is connected to climate action and sustainable cities and communities, including the buildings. And we will do this here in the spirit of partnerships for the goals. And you can see there's a long and very successful collaboration also with you in Australia. And especially my friend Greg was telling you something about this. I'm here to talk with you about embodied carbon frameworks. I will discuss some themes, topics, and trends. And again, my name is Thomas. I'm here this day in Weimar, where the Bauhaus comes from. Yes, if you talk about embodied carbon, it seems to me this is like talking about the elephant in the room. It's a big thing, but in a certain way, we missed in the past to discuss this in an appropriate way. So what we are talking about, if we are talking about embodied carbon, here you can see a piece out of a European standard describing the model of a life cycle of a building. You can see the life cycle stages from product stage to end of life stage. And these stages are subdivided into information modules. And this is the basis to describe the system boundaries, also system boundaries for the embodied carbon. You can see here the green parts starting with raw material supply and ending up with disposal. More or less, this is embodied carbon. And you can see left-hand side surrounded by the red dotted line, the so-called upfront emissions. We will come back to this later on. And in a certain way, you and I, we have to learn this like a very specific language. It's life cycle impact assessment language. And this is a certain way to agree on a certain type of language, specific system boundary. It's very necessary to achieve a minimum level of transparency. And, dear colleagues, we have to look at this from two perspectives. First, there is a macroeconomic perspective. And from there, we can say around about 40% of energy-related carbon dioxide emissions can be allocated to buildings, and around about 10% can be allocated, in this case, to construction industry, and this includes construction product manufacturing. This is the global perspective and a macroeconomic perspective. But we can do similar things for the buildings, for building life cycle. My colleagues and I, we have done some surveys here, taking into account hundreds of life cycle impact assessment results, dealing with the life cycle of a building, and what can we learn from this. In the past, we are very successful to reduce energy demand in operation and operational greenhouse gas emissions, but we have paid the price in a certain way with higher with higher embodied energy and higher embodied emissions. So what we can say is the relative and absolute importance of the embodied emissions is growing. By the way, there is a trade-off for sure, but this is no longer a must. If we are doing well, we can reduce both the operational and the embodied part, and this is the task in the future. I was searching to learn more about the situation in Australia, and I was able to identify this piece of work here to learn more about the current barriers. So in a certain way, there is a lack in regulation and incentives, and they are, your colleagues in this case here come out with a statement, there's also a certain deficit in building codes. So we are in a similar situation, and that's why in the spirit of a good partnership, we can exchange some idea and try to support each other. And this, dear colleagues, this is one of the main outcomes so far in the International Energy Agency 72 program, a checklist for a framework on embodied carbon. I will go through here to explain what is important to understand in a much more better way what is covered by embodied carbon. So first of all, we need a good model of the building. We must describe the included parts and components. We need a model of building's life cycle, especially we have to clarify the included life cycle stages and modules, so with or without replacement, with or without end of life. We must have an agreement about the appropriate indicator, global warming potential, dealing with all the greenhouse gas emissions, but there is a certain granularity. We will talk about a total or just the fossil part or just the biogenic part. And in some cases, they are just dealing with CO2. In our days, we will ask for the total, but as additional information also to show the fossil and the biogenic part. We need the source of environmental product information. It comes out of a database or product-specific environmental product declaration. We need very specific rules for bio-based products using different approaches. We need some allocation rules for embodied impacts of building integrated photovoltaic systems, how to allocate the system to the building. We need a well-defined reference study period in Europe, in most of the cases, 50 years. We need some replacement scenarios, and for this, we need information about service life of building components. We need specific end-of-life scenarios, especially to talk about this will go to end of life or it will go for recycling. We have to deal with additional information. Module D1, this describes a so-called recycling potential, but this is just additional information. And we can also talk about additional information related to the carbon content, kilogram C, in the building itself. There is the influence caused by the energy mix, and we can discuss, we will go from a more static to a more dynamic approach in the description of the energy mix and the current and future emission factors. We can discuss discounting if we like to compare current and future emissions. By the way, there is no physical discounting. And for sure, we have to discuss possibilities and rules for offsetting. Here, you can see some typical values from Europe. And you can see left-hand side, if you try to compare different types of buildings and use, you can see there is not such a large difference between different types of buildings and use. And right-hand side, you can see a more detailed picture. And I was invited also to give you a quick overview about situation in Europe. Here we have a more mixed situation. There are large activities in the northern and western part of Europe going into the direction of legal requirements to limit greenhouse, not only in the operational stage, but in the full life cycle, including the embodied part. But there is a more specific situation in different countries, and therefore I like to show you some examples. Frontrunner is now France. There is already a new regulation in place, And here you can see left-hand side in French language, there are limits for the embodied carbon as the value per square meter. If you go to Denmark, they will start now a new activity for legal requirements, but you see also right-hand side, there is something like a timetable. So industry practitioners, designers are well informed about the next levels of demands and requirements. So this is also very interesting to make a forecast for the benchmarks of the future so that industry and all the practitioners can prepare themselves. Situation in Germany, we are waiting for new regulation, but there's already a funding program. Here we have benchmarks to limit greenhouse gas emissions in the full life cycle of the building, including the embodied part. And if we go to Switzerland, there is a standard for designers and engineers. And here it's very important to say there is a requirement, but there are also guiding values, especially for the construction, meaning the embodied, and guiding values, especially for the operation part. And you can see this is also for new buildings and larger refurbishments. And there is a new, let us say, type of actor. It's no longer national government. In some cases, cities are quicker and better because it's easier to make a rule for a city. And here you can see an example from London. And London is including already requirements to limit embodied carbon into public procurement. By the way, it's very important to see the connection between building and product level. In Europe, we are waiting for the next version of construction product regulation. And you can see left-hand side, there is a top-down approach, starting with basic requirements for construction works and ending up with requirements for construction products. From there, we go for requirements for environmental product information, right-hand side, and we must bring back such information in the design and decision-making process at building level. We will come back later on again to this during our discussions, I think. In the current draft for the future construction product regulation, you can see there is a demand for minimizing whole life cycle greenhouse gas emissions in the life cycle of construction products. And you have also to communicate such information. And you can see a new level or a new list of essential characteristics to be covered, and climate change effects is a mandatory part at such a list. But look to the very last line. We must also deal with a new exercise to say how we can store carbon in products and buildings. I will end up with some quick recommendations. First of all, for the policymakers, for sure we need at the moment a national method for environmental performance assessment. And so life cycle carbon is one part out of it. We should, or you should, introduce legal binding requirements to limit greenhouse gas emissions. From our point of view, this should be done by 2025 with a roadmap to net zero emissions in 2035. There is a combination between circular economy and embodied carbon tasks. So think about the requirement to limit use of natural resources. We must develop guiding values for embodied greenhouse gas emissions and as a subcategory for upfront emissions. And we should introduce legal binding requirements to communicate environmental construct product information. This can't be a voluntary system in future. And for sure, you should provide as a service a national database. For the clients and designers, first of all, I like to highlight, yes, there is a strong job sharing between client and designer. Client is responsible for any kind of decision and designer will support this. So for the client, follow a sufficiency strategy, reuse or repurpose existing buildings first, include embodied carbon related requirements into your client's brief, and provide designers, also very important, with enough time and money to assess design options. And for the designers, design for flexibility and adaptability, design for deconstruction and recycling friendliness, selection of low carbon products, and assessment of environmental performance already during design. And for sure, you need a certain education to deal in future with life cycle impact assessment tools and methods. And we end up with recommendation for construction product manufacturers. They are also today with us here. Please provide product-specific environmental product information, like average and minimum service life, whole life greenhouse gas emissions, content of materials, and provide sector-specific environmental information like sector EPDs for early design stages as average values, provide take-back options and increase content of recycling materials, and provide decarbonization strategies. So we will have in future databases, not just with current data, but also with a forecast, especially if we think about replacement. So let's reduce the carbon footprint of buildings together, or let me express this in the terms of a national poet here in Germany. So Goethe, in my hometown Weimar, would say, words are not enough, let's take action. Thank you.
Thanks so much, Thomas, bringing a bit of flavor into the webinar. Appreciate that. That was a really great overview of the issue that we're talking about today. Thomas and Greg, really appreciate that. And I was just thinking as you were speaking, Thomas, about the elephant in the room. I mean, it's good that we're finally at the point that we're addressing the elephant in the room. That means we've made some progress on reducing operational carbon, and now we have at least a little bit of free space to begin thinking about embodied carbon. So I think that means we're moving in the right direction. So next, we'll hear from someone working directly on one of the reporting frameworks that we've been talking about, Ivana Brown. Ivana is the sector lead for accelerating net zero buildings at the National Australian Built Environment Rating System, or NABERS. Ivana is leading the development of a new framework to measure, verify, and benchmark embodied emissions in buildings. Ivana's expertise is bringing together policy objectives with industry needs to deliver action on climate change. So Ivana will present on the early thinking NABERS has been doing on embodied carbon in the built environment and the market research to accompany that thinking. Take it away, Ivana.
Great, thanks Julianne for that introduction. I'll share my screen and get this kicked off. Yeah, so yeah, my name is Ivana Brown. I'm working at NABERS, and I'm going to talk to you about the embodied emissions framework that we're developing. So it's a new framework, and it's intended to articulate how to measure, how to verify, and how to benchmark embodied emissions of buildings in Australia. I'm going to talk a little bit about some of the market research that we undertook that underpins why we're doing it. I'll talk a little bit about the rationale for how the framework is being designed, and then I just want to end with just to touch on how NABERS is a tool that works really well with policy to deliver outcomes. So I thought I would actually, just because we have a lot of people on the call may not all know who NABERS is. NABERS is a national government program to provide really simple, reliable and comparable sustainability ratings for buildings in Australia, for building performance. We are kind of the language for building sustainability here in Australia. We do a star rating system, so building owners will submit their measured performance to us. And then we'll certify and benchmark and give them a rating from 1 to 6 stars. And we certify on a lot of different things. So energy is what we've been doing the longest, but we also do water, waste, indoor environment quality. And we cover quite a lot of sectors. So we started off in the office space and kind of have moved out to quite a lot of sectors. The number of sectors continues to grow. So residential aged care and retirement living being our latest, and more coming. And we've had really a growing success since our inception. So customers that rate their energy performance with us will save 30 to 40% of their energy over 10 years. We are expanding forever expanding. So currently we do over 3,500 ratings every year. And every year we're growing not just the number of people participating in the sectors that we already cover, but also we expand to new sectors all the time. So we're forever expanding and exporting. Like, we've been so successful that we've been able to export out to the UK and New Zealand. So I'm going to touch on the market research that we undertook to really define what is the problem that we're trying to solve, and you know, why should we be looking at this. It's just a couple of highlights, but I just want to say that in doing the research, we went and spoke to a lot of the marketplace here in Australia, you know, over 150 individuals across over 90 organisations, and a real breadth of people and organisations. And one of the first kind of really key findings was that the industry told us that there really is a problem with no clear solution. So everyone who's measuring embodied emissions kind of does it in their own way. There's lots of decisions that you need to make when coming up with a number, like what scope, what emissions factors do I use, what parts of the building. So there's lots of decisions you need to make, and it's kind of all that together is kind of making the industry quite fragmented. Like, everyone's kind of doing it in their own way, and really difficult to kind of compare performance from one building to the next. The other thing that we heard a lot of is there is a very strong desire for NABERS to develop a framework. So they told us that they see industries really mobilizing in this space. So, you know, forward-thinking players are already starting to reduce embodied emissions of buildings. And they want NABERS to help align industry and focus their attention. So they want to spend more time on focusing on how do I reduce emissions as opposed to how do I measure emissions. And it was a similar story from both the designers and the builders and the developers, as well as from the investors and the policymakers. They want to be able to kind of define performance, but without having to worry about how they're measuring it. So that's kind of where NABERS can step in. So next, I just want to talk a little bit about the rationale for how we're developing the framework. And the very first thing that we really needed to do was to come up with what are the objectives that we're trying to achieve. And I think this kind of goes back to Greg's point that, you know, there's lots of different ways to do it, but you need to make sure you do it in a way that's appropriate for its use. So that's kind of what we're trying to navigate. And the first thing that we did was come up with the objectives, which is we want to be a tool to support behaviour change to urgently reduce emissions. That includes from the design right through to the construction. Focus primarily on measurement, verification, benchmarking and disclosure, which is really the core business of what NABERS does. And focusing on the big wins first. So, you know, it's about progress, it's not about perfection. And, you know, what we release on day one, you know, we can kind of grow and evolve that over time. And that was very much reiterated by what the market told us. And so we can design something to meet these objectives, and that's great, but we actually need to make sure that whatever we design is adopted by industry. So we went and asked them what they need in order to adopt it. And this is what they told us. And these become our design principles, essentially. So much like us, they want it to be impactful to drive kind of meaningful change. And it must be consistent. So a consistent approach to produce really reliable and consistent outcomes. And those two, impactful and consistent, become kind of the real core and the non-negotiables of what they want. And the other things that they told us was it must be collaborative. So aligning with predominant ways of thinking, with the other tools and schemes that exist. Trusted. So it must build confidence through a robust, transparent and third-party verified framework. Streamlined, so it can kind of reach a broad market share, and meaningful. So outputs enable fair comparison and are easy to understand and communicate. And then this is, you know, what we're kind of in the midst of right now is designing the technical design of the framework. It has the principles and the objectives kind of at its core. And it will address these 5 different areas. So we're designing it in consultation with industry and policymakers. And how we design the framework will be so that it can provide a really consistent approach to measuring, verifying and benchmarking embodied emissions for buildings. So it would be a tool for behaviour change. And then the last thing I just wanted to touch on is how NABERS is a tool to support policy, how we've worked together in the past. So this is just a graph that shows when NABERS started to be included in government procurement policies. Government procurement policies started requiring minimum NABERS energy ratings for tenancies. And you can see over time the sort of impact that this has had in government, in the energy intensity of government tenancies. Then it was introduced into the Commercial Building Disclosure Program, a national program that requires office buildings to just disclose the NABERS rating at the point of sale or the point of lease. So there's no minimum performance requirement, just disclosure. And you can see that those buildings started off performing a lot worse than the government built tenancies. And then over time, you can see the huge reduction that this has had just through disclosure. And NABERS is the tool that policy can use to kind of implement this. So I just want to kind of end with what the potential and what we see the potential for NABERS is. And it's really to build on the track record that we have. It would be a national framework for buildings. It would be something that could be used within policy to support outcomes. And we are doing it in a co-design process with stakeholders to make sure it meets both industry and policy needs and can be utilised by all the different parts of the sector. So I might just leave it there.
Fantastic. Thanks so much for that, Ivana. Yeah, it's really great to know that NABERS is getting to work in this area, as you've shown how successful NABERS has been in reducing operational carbon. Hopefully there can be a similar impact in embodied carbon. And in fact, we've had some colleagues bringing the message of NABERS over to Thomas's neck of the woods just about a month ago. So there is interest around the world really in what NABERS is doing. And I'm sure that will be the case for when hopefully an embodied carbon framework gets up and running. So thanks for that, Ivana. And last but certainly not least, we will hear from someone actually doing this work on the ground on the day-to-day, and that is Cyril Gerard. Cyril is the head of sustainability at Holcim Australia and New Zealand. For the past 20 years, Cyril has focused on statutory approval processes, stakeholder engagement, environmental practices, and sustainable solutions across French and Australian jurisdictions. Cyril has been leading Holcim's endeavor to be a leader in sustainable construction with the development of environmental product declarations for Holcim's products and low carbon solutions. Bit of a tongue twister there, apparently. Great to have you here, Cyril. I will pass it over to you.
Thank you very much, Julianne, and very pleased to participate to this forum, and very pleased for the diversity of speakers also, because really we've covered a range of different topics from what it is that we're looking in data and how we need to standardize it, down to the different requirements to lower embodied carbon, up to rating schemes, and really it comes now to what's happening at the product level, and that's really what I want to cover today, because really when we talk about concrete, and I work for Holcim, I'm the head of sustainability of Holcim, and we produce concrete aggregates, precast concrete across Australia. We've got about 250 sites, so a large footprint, and it becomes very important for us to understand that when we talk about everything that we've heard before, whether it's about measuring embodied carbon, whether it's about disclosing these numbers in terms of in a consistent way, and how we then use this data to reduce embodied carbon, that's exactly what's happening today in industry. And I'll go through that little journey with Holcim so that you can get a bit of an insight to what's happening behind the scene and the options that you have when we talk about low carbon products and low carbon solutions. So, and if you don't see my screen, please stop me, but I'll continue on that basis. So what's happening now, and what is being done to reduce embodied carbon in materials? And the first thing to recognize is we are really part of a bigger ecosystem. We've heard a number of people today, but there is a number of ways to reduce carbon in construction, from building nothing to building very efficiently. And we tend to really operate in this construction phase where it's about building clever. So how do we provide to the market better products? When I say better products, it's also products with better disclosure of data associated with it. But also really, and we've touched base on this before, how do we provide more information early on the planning and design phase so that we can have this impact, positive impact at the end when the building is actually constructed. Very important to remember that when it comes to embodied carbon, the carbon is encapsulated in your building at the time you pour your concrete in this instance. After that, it's too late, and it's going to remain that way for the life of the asset, whether it's 50 or 100 years. So that early choice and the choices that we're making today through our procurement processes and choice of material are extremely important down the track. So today we have to make the difference, very different to operational carbon, where we can continuously improve our building and the way they operate. I'm going to go back to very much the basics when we talk about concrete, so that we're all on the same page and we all understand what is the game changer here and what we're trying to do. When we talk about concrete, it's basically essentially like a cake recipe, right? You've got a flour with your cement that basically like bind everything together, and you've got your gravels, sand, water, and air. This is kind of the typical mix. However, these 11% of cement, and Julian reminded us that in her introduction, cement is requires a lot of energy to be produced and also releases CO2 as part of the manufacturing process of it. So these 11% of cement represent 80 to 90% of the footprint of your concrete. So the more you can reduce the impact of your cement and the more you can replace cement by other material, the more positive impact you're going to have, embodied carbon, and essentially reduce that footprint. How does that translate that into a little graph or into a little representation? That's that slide, which is very new. 4 years ago, we would have never been able to put a slide like this together. But introducing life cycle assessment into our industry and understanding the embodied carbon or the global warming potential of our products through a methodology. We've talked a lot about EPDs, environmental product declarations today. This is the methodology that Holcim follows and encourages all industries to follow. You can see on these graphs that every little light gray square represents footprint for cement. So Holcim general blends concrete, which is normal concrete for Holcim, without anything replaced, this cement component is very significant. For us, being able to measure in a standardized way all these mixes, we then try to understand what the industry has been doing by replacing cement by other materials. So cement has the capability to be replaced by two different type of byproduct of other industries. One being fly ash, which is a waste for the coal-fired power stations, and slag, which is a waste or a byproduct of the steel industry, which have properties such a way that we can replace cement by these products. As soon as we replace cement by these products, you can see that the overall footprint of your product reduces significantly. What is very important in that slide, though, is that even though the industry has been doing this for pretty much, in Australia anyway, for pretty much 20 years when we started to replace cement, this is really, really new to be able to provide the numbers associated with this replacement and to be able to shift from percentage of replacement to actual embodied carbon in your mix. That is, and you've heard all the conversation before, has been about databases, sound environmental data, environmental product declaration, how that fits into life cycle assessment. We've heard about France having kilogram of CO2 per square meters. That's with these accurate data that you can be able to start to compare materials between each other and make the right choice for your the right choice for the right product for your project. So we tend to talk about low carbon solution or low carbon concrete as something being very innovative or something of the future. That is definitely not the case. There are solutions available today, and by pushing this replacement of cement that are available. And that's this graph, I developed this graph in 2019 now, when we put forward our first environmental product declaration for concrete in Australia, which for the first time, you are able on the same graph to put the strength of your concrete. So for people familiar in concrete, it measures in MPAs, so megapascal, 20 to 50. Put on that graph also the type of different blend. Don't forget that when we talk about concrete, it's definitely not one mix. I think across Australia, Holcim has about 15,000 different type of mixes. So huge diversity of application and mixes that we have, different type of mixes for different states. So the ability to put these mixes next to each other, and for the first time now, being able to correlate the strength and type of mixes with the greenhouse gas emissions, so the global warming potential, and being able to compare performance, environmental performance this time between products. That is really the game changer. When we talk about LCA, and Thomas talked about the education and the importance of education around life cycle assessment is definitely a journey. I mean, for us as a manufacturer, learning what life cycle assessment is, what embodied carbon is not an easy task. But once we had these numbers, it was really about how do we make these numbers easy to people to understand. And that's where this last bar, these green bars that you have here, is essentially the best performer of the range. We've put a name to it, so there's a brand, so it's called EcoPact in this instance, and the definition of EcoPact is 30% to 60% reduction of embodied carbon compared to a reference case, and the reference case in this instance comes from an Australian database, which is the OZLCI database, which is the one that we recognize, or that's a reference point. That definition then becomes really important because how do we drive demand? How do we drive change in behaviors of building and choosing material with this type of solutions? Having a brand associated with the definition attached to it, you've got the assurance to have a better performance from embodied carbon than your standard product. And this is really how that translates, right? Making it easy. EcoPact is about making it easy to understand in this world of quite complex terms of life cycle assessment and standards. You've got your standard concrete mix, 0% obviously reduction. You then start to push cement out and use by product and have that reduction happen to 30 to 60%. For us, very, very important for that credibility to have that third-party verification through the EPD program. So you have verifiers, you have life cycle assessment specialists that actually do this calculation, and that's then publicly available on the EPD Australasia website. And we acknowledge also that this is a journey, so there is a remaining carbon associated with the product. And whilst the entire industry is decarbonizing, we do have to have a solution today, and the solution today is the implementation or the use of carbon offsets to essentially offset the remaining carbon if you decide to do so. So we also paired and got certified with the Climate Active program, which is an Australian government program, whereby we are certified to, after that calculation of remaining carbon, to offset this carbon to have, and this was the first time that we put in Australia that happened, to have a carbon neutral concrete. And this is, again, very significant for Holcim, very significant for the industry, but also very significant for anyone out there who's got programs with very clear targets to net zero. We talked a little bit about the different actors in the supply chain. It is fair to say that when we developed and put together our EPDs and disclosed and clarified these numbers and being very transparent about the impact of our product and the performance of our product. We also understood that really the real change happens when we specify product in a project and at the procurement phase. So this is a very easy things to remember, but when you ask for low carbon concrete, what do you need to look for? Where you need to look for, how do you actually measure performance today? In the terms of Holcim, it is EPDs, and these EPDs by the Australasia program, EPD Australasia program, actually follow EN 15804, which is the European standard, which is best practice. So have that standardization across all products. And if you want to go carbon neutral, having that stamp and that certification, again, third-party verification about from Climate Active is something to look for. How to specify? I mentioned this before, the days where we used to specify replacement of cement, so X% of replacement of cement, these days should be gone. We see that still a lot, but what that means for us, if we can't go in the background and come back with a solution with the supplier, with the client, the customer, the builder, to say, give us an embodied carbon number, and we will go and work our recipes to match that number, rather than being very prescriptive around how you're going to achieve that, for example, by a percentage of cement replacement. So really the word here is about early engagement, procurement. But the earlier you engage with the manufacturer directly, the earlier you can have a solution that's fit for purpose. And that's really a key difference when we want to achieve sustainable outcome, and collaboration is definitely more than ever paramount to success. What's next? And I'll go very quickly in this, but what's next is, from Holcim, from an overall organization, this is the things that you need to look for also for manufacturers themselves. In the case of Holcim, we were globally the first to say we will be net zero by 2050. And by the way, we will have our 2030 and 2050 targets, both validated by SBTi. That's only 7 companies in the world, cross industries at the moment. But we also, net zero climate pledge is one of them, is one goal, but you also have the circular economy piece, the water and biodiversity area, and how we integrate our community, which is very important. So sustainability is obviously way more than just embodied carbon. That's important to remind it. What's important to remember, though, in terms of the industry landscape in Australia, widening this beyond Holcim in Australia, is last year something significant happened in the industry. The CIF, which is the Cement Industry Federation, and CCAA, the Concrete and Cement Australian Association, have come together and put forward a decarbonization pathway of the Australian cement and concrete sector. This is the commitment from the Australian industry to be net zero by 2050. So we expect, and we will work towards reducing the embodied carbon of our product and have that pathway to net zero, so that our scope 1 emissions, which is the scope 3 emission for everyone that are buying our products, are reduced along the way. There are a number of different pathways to achieve that net zero, including carbon capture for the remaining carbon, especially for the carbon that is associated with the chemical reaction of producing cement. But all of this, whether it's about electrification of the operations, whether it's about building more with less, better designs, whether it's about more smarter cement, and pushing to continue to push the replacement of cement, are all solutions that are available and that will be available and are all explored to achieve this. And that's it for me.
Fantastic. Thank you so much, Cyril. That was super comprehensive. And I will just jump straight into the panel discussion, noting that we only have 20 minutes left for that. So really great presentations from everyone, but we'll get to some questions now. Thomas, Ivana, and Greg, if you would like to turn your cameras on, and join us for the next 20 minutes. That would be great. So I will go ahead and ask a question that I see Greg is typing to Alistair's quite comprehensive question at the moment. So we've been talking about these different reporting frameworks and ways of measuring embodied carbon, and the long checklist from Thomas as well of different things to consider when embodied carbon is being measured. So I'm just wondering, how do we go about standardizing and harmonizing all of these different approaches? Is that something that we can do across countries and international level? Is that something that we should do? Where do we start with actually harmonizing all of these approaches? And I might start with you, Greg, if you feel comfortable beginning to answer that question or reflecting on thoughts around standardization and harmonization.
Yes, thanks, Julian. And Thomas certainly will jump in. These are, in fact, the purpose for the two IEA's annexes. The first one, the Annex 57, that went deep into the embodied carbon greenhouse gas emissions assessment and terminologies and metrics and so on. And then in the Annex 72. So it's really looking at all those details that are raised by industry and other people over many years. And the main thing is to look at the fine technical issues around clarifying meaning, clarifying, being very specific about what's covered or not covered in terminologies, even frameworks that take into account a whole lot of things that sometimes are ignored and not explicitly identified or stated as being not included. So it's about clarification, about harmonization and prioritization, and ranking what are the important things. It's similar to what Ivana was talking about, something to start with versus perfect. And so in the IEA Annex 57 and 72, we looked at all these issues and figured out, okay, what are the most important things, particularly in this usage of terminologies and definitions and how things are calculated. And if you have these differences, what would be the outcome differences, for example? And we compared the different country practices and also the literature, published literature on the topics, on various topics across these different factors. Thomas, anything to add?
Yes, in a certain way, I like to add something. From my point of view, if we are discussing the appropriate starting point, we should follow a top-down approach. At first, we should start with so-called science-based targets. You know, there's an overall budget of remaining greenhouse gas emission to stay below 1.5, or if you like, to stay below 2.0. And from there, you can think about remaining budget. And I'm afraid 2050 is too late, much too late. It's not a question of selecting 1 year in a calendar. It's a question of what is there, what is still there as a budget. And following the different scenarios, perhaps already after 2035, there is no longer any kind of budget. Therefore, first of all, we have to speed up a little bit. Next, we should avoid to call it a complicated exercise because, you know, this creates additional barriers. From my point of view, it's not such a complicated exercise, especially for designers, because it's very similar to life cycle costing. You will not use money, but kilogram of CO2, but it's very similar. It doesn't matter you are dealing with money or kilogram CO2. It's very similar if industry is able to provide us with appropriate data like Curl was showing and explaining to us. And we need, in addition, appropriate design and assessment tools. And is such thing available, it's an easy exercise. And so my recommendation is to think about different starting points, especially if you look to Europe, there was a Green Deal, but there are different strategies. So if you come from the point of energy, in future, we will ask the engineers to include the life cycle carbon into energy performance certificate as additional information. So there is a link to energy. If you are coming from sustainability assessments, there is a European assessment result reporting system called NABERS. And in NABERS, there is a must to deal with life cycle related greenhouse gas emissions. And if you are a member of financial industry, your category, your way of thinking is financial risk and economic advantages. And also in this case, you have already to show to your bank the life cycle based carbon footprint. So in a certain way, we can learn out of this for sure. And Greg was right. There is a basket of different needs and tasks and so on. But at the very end, we have to translate this into the working surrounding of the specific actors to integrate this into their decision-making process and to organize a flow of information between the, let us say, built environment specialists, let us say. Yes, you know, we are missing in a certain way this team spirit of medicine. We are a subdivided industry, subdivided into different interests, but we should create the spirit and the job sharing of built environment professionals. Thank you.
Fantastic. Thank you, Thomas and Greg. Do any of our other panelists have anything to add on this question around standardization, harmonization of different measurement approaches to embodied carbon?
The only thing that I would add is, and I've talked a lot about EPDs for concrete, but as at a manufacturing level, and there was a great question in the chat about the signage industry and, you know, using aluminum and steel also. Every industry is going through this process of what does that mean for us embodied carbon, and I think, like Thomas says, we can't say that it's very complicated. You have to check it down, and our responsibility as manufacturers is to disclose. And I think if you interact with manufacturers, these are the questions that you can ask. What are you doing to understand your embodied carbon? How are you measuring it? And do you have a third-party, verified methodology that you're using to do that measurement? That's really the first step, and that definitely what happened with concrete in Australia anyway, where there was very, very little information about concrete, and therefore all the rest of the decision-making process is very complicated because you can't compare apples with apples.
Excellent. All right, so I might move on to one of our other questions with the short amount of time we have in mind. Jill Armstrong has asked a really great question around the challenges of calculating embodied energy in existing buildings and whether the NABERS embodied carbon framework will incorporate existing buildings. So we've been talking a lot about the construction process and whether, or the emissions involved with building materials and actually constructing buildings, but is the refurbishment of existing buildings, you know, something that we're also involving in this conversation? And is that something that NABERS is thinking about at this point in time as well? Ivana, do you have a response to that?
Yeah, so I guess in the interest of kind of our goal of progress over perfection, you know, we are going to start with the quick wins, which will focus on the new build rather than the existing sector. That would include major renovations, you know, and so there'll be some work around defining what that is. But there's, yeah, you know, how we grow the framework over time and how that does include existing buildings in the future. Like I think that's an open question and we need to work that out.
Fantastic. Any reflections on the challenges with existing buildings from any of the other panelists? Thomas?
Yes, so there was a longer debate in Annex 72, how to deal with embodied energy and embodied emissions in already existing buildings in the case of larger refurbishment activities. And we can learn from the economic experts, never look back, look into the future. And in this case, we will not look back to energy we have spent 50 years in the past. We will look to the current value of such a building, and you can call it like, it's a transformation from cost to value. You know, existing building is representing in a certain way an environmental value also. But in your calculation, you can start with 0 for the existing part, because this was allocated to the life cycle of the existing building in the past. And so you must not produce new construction products, just if you like to put in some additional ones. And this will create an advantage for the refurbishment. And in Europe, there is a really wave to ask for renovation first, let us say, to realize environmental value of existing buildings and to explain, yes, it's one option to save embodied emissions if you are able to enlarge the service life of existing building. And this is one of our main strategies. But you know, it's very important that in future, the designers are able to follow a strategy designed for flexibility and adaptability, also to enlarge the service life of the new buildings. And this is close in line also with the idea of circular economy or circular buildings, let us say, long-lasting buildings. So durability is a keyword here, yes.
Excellent. And Greg, did you have something to add?
Yes, in the same concept essentially, but the only thing to add is that to say explicitly that it's sunk-in cost, the one we already have, essentially. So the idea is only the ones that need to be replaced or upgraded. And when we talk about upgrading, it can be for utility, for aesthetics, or it can be for energy efficiency itself, right? Or when we put solar panels or we put energy retrofit, then that's when you do the life cycle of balancing the operating energy, operating carbon savings with the additional embodied energy, embodied carbon in doing so, and doing that basis. But essentially, that should be the priority. That's why we've been focusing on that one, because then that's virgin materials and emissions that you avoided, the ones that you already have. And this is 97%, 98% of the building stock. The new ones are very small part. The replacement rate is very slow. Which brings me back to the first question and Ivana's answer a little bit about or the discussion about what we should do, for example, in Australia. It would be, these are the things that we looked at, as I said in the beginning, in great detail in Annex 57 and Annex 72. And the tragedy is that if a country starts from scratch and not take into account the amount of information that's already been discussed extensively and produced in some of the reports and papers from both 57 and 72 in particular. So I think there's a lot of information there that hopefully can be used by specific countries, in particular by NABERS and here in Australia for various purposes.
Excellent. Thank you for that. So I think we've got time for just one or two more questions. I do have an audience question before I might throw it back to Cyril and talk about the manufacturer's perspective in the last instance, but we've got a question from Rado Zulak, apologies if I butchered that. Which LCI or LCA databases are most popular or relevant in Australia? Any panelists care to jump in and answer that one?
So this is about practice. So it depends on what people use, and some people tend to use what they're familiar with. But it would be obviously the EPIC database from the University of Melbourne that Robert Crawford and company have developed over the years, and also of course the EPD information and also LCI database from process-based. There are a number of other things that are out there. Different people use their own databases in conjunction with other places. So, but it's probably a matter of surveying the people who actually use these things. From what we know, it would be these two things that are used heavily. Because of the availability of the input-output tables, for example, for certain purposes, you can also use them from two sources. Which, to answer Alistair's question in the Q&A, he's right that if you build it from the more detailed data sets of a process-based data set from the very beginning, because you just have more details there, then that would be the starting point. It's just that when you don't have these kinds of things, then you move up to the hybrid and or input output. But again, in the end, it's about the questions you're asking on which one to use. But for purposes of products and building, most of the decisions we have to make. And for product manufacturers, for hotspot analysis, for example, to find out how they can reduce, like what Cyril showed, where you can reduce, you really need the detailed process data sets. Thomas.
Yes, and at the moment, perhaps you are in a certain way free to select your own database. But if Australia decides to go for legal binding requirements to limit greenhouse gas emissions in the life cycle of building, you must also define the source of data, because in a certain way, the method, the data, the database, and the benchmarks are creating one package. And therefore, if you have, let us say, requirements like target values or benchmarks, in this surrounding, you must define your database, and you should use one national database in a certain way. And Cyril was kind enough to make clear that there are European standards all well accepted in Australia, not just from Holcim, but also from other construction product manufacturers. And there is a well-defined way to offer, let us say, environmental product-related information. And therefore, you need something like a harmonized database if you like to go for official benchmarks.
And what I will add to this in terms of the EPD landscape, so this very detailed data, what we see with the program is an explosion of industry starting to embrace that that methodology, and I really invite you to go to their website and have a bit of a look and see what's available there. But there's definitely it's new for most industry, and most of us do not have LCA specialists in-house also. So that is that process of understanding what we need, why we need it, and access that expertise to develop this data.
Great, thanks all. And Ivana, just to bring you in on that question, did you have any reflections on kind of the data sources and where those things are coming from that NABERS will be using when it starts getting the embodied carbon framework running? Is that something that is beginning to be thought about, or is that kind of a future next step thing?
We are in the thick of defining data sets. That's part of it's one of the 5 areas, the underlying data that you use and the emissions factors. So that is and the calculation methodology, that's very much in what we are in the thick of kind of working through at the moment. I guess to answer the question around what we heard from the market in terms of what people are using, it's very much like what Greg and Cyril said, like EPDs and the EPIC database is kind of what people are using. And like different, at different types of the times in the project, they might be using different types of data sets as well. I think there can be issues with mixing and matching different types of data sets. So those are all like part of the things that we kind of need to work through, is making sure that where we do prescribe like a methodology in a data set at the design stage, that it still makes sense at the construction stage, because that's really where we will be benchmarking and verifying the data. And so you don't want to have stuff kind of like jumping around.
Yeah, there are lots of problems with that. Mixing, comparing apples and oranges, as you can say.
Yeah, exactly. Yep.
Absolutely. Okay, well, unfortunately, we are actually out of time. That went very quickly. I did want to thank everyone for tuning in this evening, especially for those in Australia. It's 5:30 p.m., so you stuck around a little bit after work hours, which is great. Thanks for that. And I did want to thank our speakers today for sharing their insights on what should be an emerging issue, continue to be an emerging issue in the coming years, particularly as these conversations continue and governments begin considering their role in this space. Thank you to MECLA for taking the lead on driving action in this space. It's really been a pleasure partnering with you on this webinar. And thank you again to the Department of Climate Change, Energy, the Environment, and Water for supporting this webinar as well.